Right, we need to find the volume of the solid obtained by rotating about the y-axis. So this time it's about the y-axis, the region between y equals to x and y equals to x squared. Now we're using the cylindrical shell method. Alright, so if we sketch this quickly, we know that y equals to x, it's a straight line passing through the origin. Y equals to x squared, something that looks like that. Alright, so this is y equals to x squared, this is y equals to x. Just label your axis. This is y and x as the origin, and we know this is the region. Again, to get the point of intersection, you equate both graphs. X squared equals to x, and if you solve for x, you see that x is 0 or x is 1. Alright, so this point here we know is going to be 1, so x is 1, and if you substitute, you just get y is 1. Alright, so that point is 1, 1. That is the shape. Now this says about, it's about the y-axis, so it means that indicate your axis of rotation. We know it's going to be about this axis. It's about the y-axis. What do? We need to draw the rotated piece. We know that, okay, if you rotate this side, you're going to have something that looks like this. So this will just be the straight line piece. Alright, you have something that looks like that. And if I have to draw a shell, how it works is you draw a disc that touches the outer surface, and then you make the height of the shell to be the distance between the two graphs. So notice that this height here touches both graphs. Alright, and there you go, you have your shell. Alright, now to solve this, we need to find, remember that the volume here is, we need to find the radius, and we need to find the height. Alright, so we need to find what the radius is, and we need to find what the height is. Alright, so what's the radius here? So the radius, if you notice this distance here, is just some unknown x values, just some x value, and the height is the distance between the two graphs. So it's top graph, which is the straight line graph, minus the bottom graph, which is the parabola. Alright, take note, we're integrating in terms of x because now it's cylindrical shell method. So when it's about an axis, we swap the variables. Alright, so it's in terms of x. And your volume there would just be integral. In terms of x means we're going to move from 0 all the way to 1, and we're going to say 2 pi radius times height. Alright, so 2 pi radius times height dx. Alright, and if you solve this, you just have 2 pi x cubed over 3 minus x to the 4 over 4, 0 to 1, you just have pi over 6. Alright, so what have we learned? We've learned that using the cylindrical shell method, you swap axes with, so the recipe for the Dix and Washer method, you just use the opposite of those recipes when doing cylindrical shell method. And to draw your cylinder, again, we say you draw a disc touching the outer surface, and the height of the disc will just touch both graphs. Alright, and you need to find the radius of the disc. We say the radius there is just some x value, and the height is top graph minus bottom graph. We integrate in terms of x because it's about the y-axis.